A detailed look at the distant cosmos. We show you the latest pictures sent back to Earth by NASA's James Webb Space Telescope.
And we have no idea what happened before it. And we're still expanding, as we will forever.
When Neil deGrasse Tyson spoke about what the James Webb Space Telescope had uncovered, the astronomical community and the wider public were stunned. Webb, already known for its ability to look deeper into space than any instrument before, had captured evidence that suggested an almost incomprehensible event: the disappearance of an estimated 900 trillion stars. This was not a story of gradual dimming, nor was it a tale of galaxies slowly fading with cosmic time. It was as if whole stretches of the sky had been rewritten in silence, with light extinguished on a scale that defies imagination. Tyson, with his gift for framing science in both awe and gravity, emphasized that this was not a trivial anomaly, but a shift that demanded rethinking of our most fundamental assumptions about the cosmos. Before we start, smash the like and subscribe buttons for more updates. The James Webb Telescope has revolutionized astronomy since its first images were released. By detecting light in the infrared spectrum, it has given humanity access to epochs previously hidden, allowing us to peer billions of years into the past. Its ability to detect faint signals has brought galaxies into view that were previously invisible, and in doing so, it has expanded our sense of cosmic scale. Yet to move from discovery of faint ancient galaxies to a phenomenon suggesting the sudden vanishing of stars on the order of hundreds of trillions is something entirely different. This is not about adding details to our cosmic map. It is about questioning whether the map itself is stable. What makes this revelation gripping is not merely the number of stars, though 900 trillion is nearly unfathomable in itself. It is what their absence represents. Stars are the furnaces of matter, the engines that have shaped galaxies, produced heavy elements, and illuminated the universe for over 13 billion years. To suggest that such vast numbers could vanish challenges the continuity of cosmic history. Tyson stressed that these were not stars that had lived out their life cycles in the familiar way, ending as white dwarfs, neutron stars, or black holes. This was not astrophysical aging. This was erasure. The implications for cosmology are immense. For decades, astrophysics has been built on models that explain how galaxies form, how dark matter shapes their structure, and how cosmic expansion stretches the fabric of space-time. Webb's findings of missing stars suggest that there may be processes at work that are not captured by those models. Some scientists speculate whether the phenomenon could be tied to dark energy, the mysterious force accelerating the universe's expansion. Others have raised the possibility that entirely new physics is required, something beyond even the speculative realms of string theory or multiverse hypotheses. One of the most haunting aspects of this discovery is the silence that accompanies it. The night sky, as seen from Earth, is filled with stars whose light has traveled for thousands or millions of years to reach us. To imagine that immense swathes of that starlight have simply ceased is unsettling, like walking into a room where familiar voices have gone quiet without explanation. Tyson conveyed the enormity of this silence in human terms. If 900 trillion stars can vanish, then permanence in the universe is far less certain than we once believed. Scientists using Webb have tried to frame possible explanations. Could these stars have been obscured by massive dust clouds blocking their light from view? Webb's infrared instruments are designed to pierce through such clouds, making this unlikely. Could it be that we are witnessing stars slipping beyond the observable horizon of the universe, carried away by accelerating cosmic expansion? The scale of disappearance suggests something more abrupt, something that is not accounted for by gradual recession. These questions make the revelation even more urgent because it forces astronomers to recognize that current theories may be insufficient. The very scale of 900 trillion stars disappearing stretches comprehension. Our Milky Way alone contains an estimated 100 to 400 billion stars. The number Tyson cited is thousands of times greater than the entire population of our galaxy. This means the disappearance is not a local event. It is intergalactic, affecting multiple galaxies, perhaps entire clusters. Such scale suggests a process woven into the architecture of the cosmos itself. Tyson's commentary urged listeners to appreciate the shock of such magnitude. to let the weight of those numbers transform awe into active questioning. If such disappearances are real, then the physics of stellar evolution must be re-examined. Stars have always been thought of as reliable entities, with predictable lifespans defined by mass and fuel. A star of one solar mass like our Sun lives billions of years. Larger stars live shorter but more luminous lives. Now the question arises, is there a mechanism by which stars can cease to exist in ways not accounted for? Could there be processes that erase stars entirely, not just transform them into remnants? The Webb data does not offer answers yet, only provocations. Another dimension of this revelation is the question of perspective. Humans have always treated the stars as constants, fixed lights in the sky that endure across generations. The cultural and philosophical resonance of their vanishing cannot be ignored. If the stars can go missing in such vast quantities, then even the heavens themselves are mutable. Tyson highlighted this point not to diminish human significance, but to enlarge it, to show that our understanding of permanence is fragile when measured against cosmic change. The universe, it seems, is more dynamic and volatile than we ever dreamed. This discovery also intensifies debates around the concept of dark matter and dark energy. Dark matter is thought to comprise about 27% of the universe, shaping galaxies through its gravitational pull, while dark energy drives cosmic acceleration. If stars are disappearing, are they being absorbed into phenomena related to these invisible forces? Tyson's framing suggests that Webb may have provided the first observational clue that dark energy is not merely an abstract expansion pressure, but could be actively altering matter in ways we never anticipated. If that is the case, then our universe is not just expanding, it is shedding. It is also possible that the disappearance is linked to phenomena we cannot yet classify. Some astrophysicists have wondered if entire regions of space might undergo transitions akin to phase shifts, where the properties of matter itself alter in response to cosmic conditions. Imagine space as a vast fabric whose regions can transform, causing the stars within them to wink out not through death, but through a change in the rules that allow their existence. Such speculation may sound extraordinary, but the data Webb provides forces scientists to explore scenarios that only a few years ago would have seemed implausible. The human mind struggles with scales of time and number, and Tyson often reminds audiences of this difficulty. To think of 900 trillion stars is to think of numbers that defy direct comprehension. Yet this is the role of modern astronomy, to confront the mind with scales beyond human measure, and to insist that our theories must keep pace with what our instruments reveal. Webb is not limited by human intuition, it records what is there. And what is there now suggests a universe in flux, with events so grand they reset the way we think about cosmic stability. For philosophers of science, the disappearance of the stars raises deep questions about observation and reality. If something so fundamental can vanish, how reliable is the picture we have built of the universe? Are we seeing the cosmos as it is, or only as it presents itself through the limited channels of light and radiation? Tyson's announcement pushes the debate beyond astronomy into metaphysics, because it asks us to consider whether the universe is constant in ways we can trust, or whether its very foundation shifts beyond our ability to predict. The public reaction to such a revelation is inevitably shaped by awe, wonder, and fear. To hear that nearly a quadrillion stars are gone strikes at the heart of human imagination. Stars have always been our metaphors for constancy and destiny. Poets, philosophers, and dreamers have looked upward for millennia, finding meaning in their steady light. To lose them, even conceptually, feels like a loss of orientation. Tyson did not shy away from this, emphasizing that science is not meant to comfort but to reveal. The comfort we can find is in the act of discovery itself, in the fact that humanity has built instruments like Webb that allow us to glimpse such truths. There is also the issue of what this disappearance means for the long-term future of the cosmos. If stars can vanish in such numbers, then the universe may not gradually fade into darkness billions of years from now, as was once predicted. It may be undergoing transformations in real time at scales that bring those endings closer in ways we cannot yet define. Tyson's words carried the weight of this uncertainty, reminding audiences that science does not offer final answers but evolving ones. Each revelation reframes the questions, and Webb has just asked us to rewrite the most fundamental of them. What is the fate of the stars? In the coming years, astronomers will comb through Webb's data, cross-referencing with other instruments and building new theories. Yet the moment Tyson described remains etched as a turning point. To say 900 trillion stars have disappeared is to articulate something so vast that it seems like myth. Yet it is grounded in the precise and unforgiving gaze of a telescope orbiting beyond the moon's distance. The implications ripple through every layer of science, from physics to cosmology, from metaphysics to human meaning. The James Webb Telescope was built to look back in time, to capture the light of the first galaxies and uncover the history of creation. What it has also revealed is that even in this vastness, change is not only possible but sudden, sweeping, and profound. Tyson's revelation forces humanity to grapple with a cosmos that is not static but restless, not eternal in the ways we imagined, but shifting in ways that leave us humbled. The disappearance of stars on this scale is not just an astronomical event, it is a redefinition of the stage on which existence unfolds. The announcement from Neil deGrasse Tyson about the James Webb Space Telescope detecting the disappearance of 900 trillion stars has pushed the imagination of scientists and the public into a realm that feels almost alien. What makes this moment so extraordinary is that it compels humanity to wrestle with a universe that may be more volatile and unpredictable than centuries of observation have suggested. To add depth to this understanding, it is necessary to examine the layers of implication from physical theory to cultural resonance to the very psychology of facing the infinite unknown. Each layer opens a door to new thought, new challenge, and new perspective on what it means to exist in a universe where stars themselves may be swept away. The disappearance of such a staggering number of stars raises profound questions about the architecture of galaxies. Galaxies are not merely collections of stars, but complex ecosystems where matter, energy, and dark matter interact in delicate equilibrium. If hundreds of trillions of stars have vanished, then entire galactic structures may have been altered, perhaps even destabilized. This would mean that cosmic cartography, the great effort to map and understand the structure of the universe, might have to be reimagined. Astronomers have long treated galactic clusters as anchors in the cosmic web, their distribution tracing the invisible scaffolding of dark matter. To imagine those anchors loosening or even unraveling is to face a universe that is less secure, less predictable, and perhaps more fragile than previously thought. Another aspect to consider is how this disappearance challenges the concept of conservation. In physics, conservation laws are the bedrock of our understanding. Conservation of energy, conservation of momentum, conservation of mass energy. For stars to vanish, the question arises, where did their matter go? If the energy and mass have not been transformed into remnants like black holes or white dwarfs, then perhaps they have slipped into dimensions we cannot perceive. This opens the door to radical possibilities. Parallel universes siphoning off matter, quantum-scale processes scaled up to cosmic proportions, or even entirely new states of matter that remain invisible to current instruments. Tyson's framing of the event underscores this mystery, not as a flaw in observation, but as a genuine enigma that forces us to question the solidity of our laws. The psychological impact of such discoveries cannot be underestimated. Humans are accustomed to instability on Earth, storms, earthquakes, the shifts of history, but the stars have always been the backdrop of permanence. To learn that the universe may erase stars wholesale is to learn that even the most enduring symbols of constancy can falter. This generates a tension between awe and dread, between wonder at the discovery and fear of its implications. Tyson has always been skilled at channeling this tension into curiosity, urging people to embrace the discomfort of new knowledge. Yet it is easy to imagine how such a revelation stirs existential unease, as if the cosmos itself were withdrawing part of its narrative without explanation. Culturally, the disappearance of stars resonates in profound ways. Across history, civilizations have used the heavens as calendars, compasses, and canvases for myth. The constellations served as guides for travelers, farmers, and storytellers alike. Imagine if vast constellations vanished. The cultural continuity embedded in starlight would be broken. Tyson's announcement, though based on Webb's deep space data, echoes this cultural fragility. It is not merely a scientific event, but a symbolic one, showing that even the heavens are not immune to the forces of impermanence. Future generations may look up and wonder if the constellations they inherit will be as faithful as those we know, or if the sky itself is subject to cosmic edits that reshape our cultural inheritance. From a theoretical standpoint, this discovery may hint at mechanisms far beyond the familiar ones of gravitational collapse or supernovae. Some researchers speculate about vacuum decay, a process where the quantum field underlying the universe could shift to a lower energy state. In such a scenario, regions of space might transform abruptly, erasing the physical laws that allow stars to shine. If the disappearance of stars is tied to such a process, it could mean that we are witnessing the first signs of a deeper instability in the universe's foundation. Tyson's emphasis on the magnitude of the event invites this line of speculation, not as an answer, but as an acknowledgement of the radical nature of the data Webb has supplied. Another angle is to consider the possibility of observational limitations. Could the James Webb Telescope, despite its precision, be registering effects that are not literal disappearances, but transformations of light? Perhaps stars are being shifted into wavelengths beyond Webb's detection range due to interactions with exotic matter or gravitational distortions. This would not lessen the importance of the discovery, but it would reframe it as an encounter with new forms of light-matter interaction. Tyson's announcement encourages such questions because the very act of grappling with them advances the frontier of scientific thought. The sheer number, 900 trillion, demands another perspective: scale in human terms. To put it into context, if every person on Earth attempted to count one star per second, it would take over 28 million years to reach that number. Such comparisons highlight the enormity of what has vanished. It is not just a statistic, it is a reminder that human comprehension struggles at these magnitudes, and yet science compels us to face them. Tyson's role as communicator is crucial here because he bridges the abyss between the data and the imagination, allowing the public to feel the gravity of such vastness. The event also has implications for the future of exploration. If stars can vanish, then navigation through space may face unexpected hazards. Missions designed to travel across interstellar distances depend on assumptions of continuity. If entire galactic regions are subject to disappearance, then the very maps we would use to chart interstellar journeys might be unstable. This transforms space exploration from a question of engineering to one of cosmic unpredictability. Tyson's announcement implicitly gestures toward this, reminding us that the universe is not a static backdrop but an active environment with mysteries that could directly affect our species' long-term ambitions. On the philosophical side, the vanishing of stars forces a confrontation with impermanence at a universal scale. Philosophers have long meditated on change, decay, and mortality, but these concepts have always been grounded in human life and Earth's cycles. To see impermanence written across galaxies is to magnify the lesson beyond anything previously imagined. The stars themselves, once thought eternal, are as vulnerable to change as the leaves of a tree. Tyson often speaks about humanity's smallness in cosmic terms, but this event reframes that smallness not just as scale, but as fragility. We are inhabitants of a universe where permanence may be an illusion, and awareness of this shapes a new kind of humility. The ripple effects extend into theology as well. For traditions that have associated stars with the eternal, with divine order, or with spiritual symbolism, the disappearance of stars en masse may pose profound questions. Does the cosmos still represent stability? Or is it an unfolding story with chapters that include erasure as well as creation? Tyson's scientific perspective does not frame these questions in religious terms, but his revelations inevitably intersect with them because human beings seek meaning in the heavens. To learn that stars can vanish is to learn that even the symbols of eternity are subject to forces that lie beyond comprehension. One cannot ignore the speculative possibility that the disappearance of stars might hint at phenomena beyond natural processes. While science demands skepticism toward extraordinary claims, some have wondered whether such vanishing could be the result of intelligence on a cosmic scale. Civilizations capable of harnessing or even dismantling stars for energy. Dyson spheres, hypothetical megastructures built to capture the power of stars, have long been a topic of speculation. If such constructs exist, they would render stars invisible. Tyson's announcement did not dwell on such speculation, but the human imagination inevitably drifts there, because the notion of intelligence playing a role in cosmic architecture is both thrilling and terrifying. Even if the cause is entirely natural, the discovery underscores the importance of humility in science. For centuries, humanity has built theories of the universe based on the assumption that what we observe is representative of the whole. Now, Webb reveals phenomena that disrupt those assumptions. Tyson's message is clear. The universe is under no obligation to conform to human expectations. Its mysteries are not constrained by our comfort. Science advances by embracing the discomfort of revelation, by letting go of certainty and venturing into the unknown. The educational implications are significant as well. Young students learning about the cosmos now have to grapple with the idea that stars can vanish en masse, a concept that even seasoned scientists find staggering. Tyson's announcement will likely inspire new generations to pursue astrophysics, cosmology, and physics, precisely because it demonstrates that the universe still holds enigmas at the grandest scale. The disappearance of 900 trillion stars is not just a fact to be studied, it is a mystery to be solved, and that mystery can fuel curiosity for decades to come. From an artistic perspective, the revelation is equally rich. Artists and writers have long drawn inspiration from the stars, using them as symbols of eternity, destiny, and hope. Now the idea of their disappearance adds a new motif: cosmic absence. Paintings, poems, and novels may emerge that grapple with the void where stars once shone. Tyson's words carry into these realms because science and art share a common root in wonder. To imagine the vanishing of the stars is to confront the sublime in both its beauty and its terror. The technological dimension also deserves exploration. The Webb Telescope is itself a masterpiece of human engineering, designed to operate in the cold silence of space a million miles from Earth. That such an instrument could reveal phenomena of this magnitude testifies to the power of technology to extend human senses. Tyson's announcement is not only about what was seen, but about the triumph of building something capable of seeing it. In this sense, the disappearance of 900 trillion stars is also a story about human potential, about the way tools amplify imagination and discovery. It is worth considering how future instruments may build on this revelation. The next generation of telescopes, both ground-based and space-based, will be designed with Webb's findings in mind. Scientists will ask for instruments that can probe the mechanisms behind disappearance, perhaps through gravitational wave detection, neutrino observation, or exotic particle research. Tyson's announcement is a catalyst for this technological race, urging humanity to build even more sensitive eyes for the cosmos. The mystery of the vanishing stars may shape scientific priorities for decades, even centuries. There is the personal dimension. Tyson's ability to convey cosmic truths is rooted in a belief that science belongs to everyone. By revealing that 900 trillion stars have disappeared, he invites not only scientists, but every listener to share in the mystery. This democratization of wonder is essential, because the cosmos is not the property of institutions, but the heritage of all humanity. The disappearance of stars, then, is not a story locked away in academic journals. It is a story meant to be felt by all who have ever looked up at the night sky and wondered. The event stands as one of the most unsettling and awe-inspiring moments in the history of astronomy. It challenges physics, philosophy, art, and culture simultaneously. It reshapes our sense of permanence. It reframes our relationship to the cosmos, and it demands that we rethink the very laws that govern reality. Neil deGrasse Tyson's announcement is not an endpoint, but a beginning, a threshold into a new era of cosmic inquiry where the rules may be rewritten by the silence of vanished stars. The James Webb Space Telescope's revelation of 900 trillion stars disappearing, as discussed by Neil deGrasse Tyson, is the kind of moment that resets the boundaries of human imagination. It is a phenomenon so immense that no single interpretation captures its entirety. The implications branch outward like galaxies themselves, each leading to different perspectives on science, philosophy, culture, and the future of humanity. Having considered structural, psychological, and technological angles, it is possible to deepen the exploration further by examining additional dimensions that this mystery unlocks. Every epoch of astronomy has been defined by a paradigm shift. Galileo's telescope showed that the moon was not a perfect sphere, but scarred with craters, collapsing ancient ideas of celestial perfection. Edwin Hubble's work revealed that the Milky Way was not the whole universe, but one galaxy among countless others. Each shift destabilized the human sense of cosmic security while simultaneously enlarging it. The Webb telescope's detection of vanishing stars may represent the next such turning point. Unlike past discoveries, which added layers of complexity to our understanding, this one removes. Instead of new galaxies appearing in our field of view, familiar ones may be unraveling, leaving absence in their wake. It is an unsettling inversion of the pattern of discovery, a reminder that knowledge is not always additive. It can also reveal profound subtraction. This reversal forces astronomers to ask whether we have been interpreting the cosmos as static snapshots when it may in fact be undergoing dynamic transformations at scales we never imagined. If galaxies themselves are mutable on timescales short enough to register an observation, then cosmic history must be rewritten not as a slow unfolding, but as a more volatile process. Tyson's announcement pushes humanity into a perspective where the universe is not a museum of ancient relics, but a living system undergoing change even as we watch. The idea of stars vanishing also redefines our relationship with time. Light takes billions of years to travel from distant stars and galaxies to reach us. When we observe them through telescopes, we are looking back in time. If those stars have now disappeared, the light we see may already be a ghost, a remnant of a reality that no longer exists. This raises questions about the simultaneity of cosmic events and the very nature of time itself. It suggests that the universe we observe may not be the universe that is. What Tyson's announcement implies is not just the disappearance of matter, but the disappearance of presence. The realization that the sky may be a gallery of memories rather than a depiction of reality. The psychological impact of this is profound. To know that the light filling the night sky may be lying to us, that much of what we see could already be gone. This destabilizes the intuition that observation equals truth. Instead, observation may be an echo, and the actual present of the cosmos may be darker, emptier, and stranger than our telescopes reveal. If 900 trillion stars have vanished, scientists must ask whether there are historical precedents. Ancient astronomers occasionally recorded stars that appeared and then disappeared from the sky, supernovae, later explained by stellar explosions. Yet those were singular events, not cosmic erasures on this scale. What Webb is recording cannot be placed in continuity with those historical notes. This lack of precedent forces science to navigate uncharted waters. Without precedent, the phenomenon resists easy categorization. It does not fit into existing astrophysical models, nor does it align with recorded human experience. Tyson's emphasis underscores this point. Humanity may be encountering a phenomenon for which our language, metaphors, and theories are insufficient. The scale is so immense that we must expand intellectual tools before we can even begin to process it. This makes the discovery not just about stars, but about the limits of human frameworks for understanding. Mathematics has always been the key to making sense of cosmic data. Equations describing relativity, quantum mechanics, and gravitational dynamics have allowed us to predict phenomena before they were observed. If stars are disappearing, then new mathematics may be needed, formalisms that can capture processes beyond the reach of current physics. Tyson's announcement is therefore also a challenge to mathematicians, to find the language capable of describing absence at cosmic scales. One can imagine new models that treat space not as a uniform fabric, but as something that can thin, rupture, or dissolve. Perhaps mathematical structures like topology, which deals with spaces that transform their shapes and boundaries, will become essential to describing cosmic disappearance. Such speculation demonstrates the way science progresses. Observation drives theory, and theory creates new mathematics that then predicts further phenomena. The vanishing stars are an invitation to invent the equations of a new era. When Tyson described Webb's discovery, one implication was the long-term trajectory of the universe. Cosmologists have debated three primary scenarios: the Big Crunch, where expansion halts and reverses; the Big Freeze, where expansion continues and stars burn out; and the Big Rip, where expansion accelerates until even atoms are torn apart. The sudden vanishing of stars introduces a new possible narrative, an unpredictable erasure that does not fit cleanly into any of those models. If disappearance is a mechanism of cosmic change, then the universe's future may not be determined solely by thermodynamics and expansion. It may be determined by phenomena we do not yet understand. capable of wiping away stars in bursts or waves. This alters the human future as well. Civilizations planning to expand beyond Earth may not be heading into a stable cosmos, but into one where destinations can vanish without warning. Tyson's message carries with it this sobering reminder. Humanity's future in the stars is tied to mysteries we do not yet comprehend. The disappearance of stars also raises questions about the role of consciousness in perceiving the universe. If observation is always delayed, always seeing the past, then consciousness is perpetually out of sync with reality. Tyson's announcement makes this dissonance unavoidable. We are beings observing a universe that may already be gone in parts we think we see. This generates a philosophical paradox. To what extent is the universe we live in identical to the universe we perceive? Such paradoxes have long haunted philosophy, but now they are grounded in observational astrophysics. The Webb telescope shows us light from vanished stars, forcing consciousness to confront its own limits. Tyson's framing of this discovery does more than describe astrophysics. It invites reflection on the nature of awareness, reminding us that our knowledge is bounded not just by intellect, but by the very speed of light itself. There is also an ethical dimension to confronting cosmic disappearance. Humanity has often seen itself as central to creation, as significant within the universe. Yet to hear that hundreds of trillions of stars can vanish without warning is to be reminded of our fragility and insignificance. This can be destabilizing, but it can also be liberating. If the universe is this vast and impermanent, then the ethical weight falls not on cosmic permanence, but on how we live within our fleeting moment. Tyson's announcement encourages humility. If stars can vanish, then our ambitions, conflicts, and struggles are even smaller than we thought. Yet at the same time, the act of noticing their disappearance elevates us. No other species on Earth, and perhaps none elsewhere, has yet seen this phenomenon. Our awareness gives us a kind of dignity. Though small, we are capable of perceiving cosmic truths. Ethics may then be reframed not as asserting our significance, but as cherishing the fragile awareness that allows us to glimpse the universe at all. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 900 trillion stars suddenly disappearing from space? We want to hear from you. Thank you for watching, and see you next time.